Hi, this is BRR. In this video session, we'll talk about load balancer types on AWS. So, what are all the different load balancers we have in Amazon Web Services, and what are all the differences between these load balancer types, and how we are going to configure them. Okay. So, load balancer, like simply, the computing world, load balancing improves the distribution of network load and workload across multiple computing resources such as computers, a computer cluster, network links, central processing units, or disk drives, etc. etc. So load balancing aim is to optimize resource use, maximize throughput, minimize response time, and avoid overload on request response coming from the client to the web server. So if you look at this Amazon web services, we have three load balancers like application load balancer, network load balancer, and classic load balancer. So in AWS, we have ELB, elastic load balancing. So that is what elastic load balancing ELB supports the following type of load balancers. So if you look at the application load balancer, so the application load balancer or network load balancer or classic load balancer, basically every load balancer have the architecture like, the load balancer is being placed here, and at that particular load balancer will be having a target EC2 instances, and they're configuring as per the load balancer configurations. And over the load balancer will be having user the process request environment where the actual requests are coming to the load balancer. So the requests are coming and hitting this load balancer here. This load balancer will know then mask the actual IP address of your EC2 instance, which is behind this load balancer, and protect the security of your web server exposing outside, and available highly. It is highly available for the users because it is purely the proxy server where it receives the request. So when you send a request, immediately it responds to receive the request, and it is highly available for all the users request, and it is processing the getting requests based on the configurations done on the load balancer to the EC2 instances. So what is this application load balancer doing in this ELB configurations on the Amazon Web Services? So generally, this AWS application load balancer operates at layer 7 of the OSI model. So Open System Internet Model. This is what the model organization we are following for layers. Like we have 7 layers. It is topmost layer, seventh layer. Seventh layer is operating this particular application load balancer. At layer 7, the elastic load balancing has the ability to inspect application level content before process the request or IP address or port number you are mentioning in the URL. So this application load balancer will validate the application level content before giving processing the URL to the web server. Once it is validated, then it will verify the IP and port number. This lets the route based on more complex rules than with other classic load balancing or network load balancing. So if you can say like example of this load balancing, and elastic load balancing at a given IP will receive a request from the client on port 443. This is HTTPS. So the application load balancer will process the request not only by receiving port but also by looking at the destination URL. Multiple services can share a single load balancer using path-based routing. In like if you can say like some example, http www.example.com/login. The same domain you will be having http www.example.com.subscribe or another folder or something. We have same client would request any of the URLs. My same client means http www.example.com is a client, and /login /description /subscribe /download. These are different the requests coming from the same URL. The application load balancer will be aware of each of these URLs based on the pattern setup when configuring the load balancer, and can route to different clusters of servers depending on application need. Rules can also be added at a later time as you add new functionality to your stack. So when application load balancer integrates with EC2 container services using service load balancing, this allows for dynamic mapping of services to port as specified in the elastic, the container service class definition. So this way this application load balancer works. So when request receives from the web browser to the application load balancer, it will check the application level content before verifying the IP and the port number of the URL, and then it will process the IP address towards this EC2 instances. So coming to the next load balancer, network load balancer. So what is this network load balancer? So network load balancer makes routing decisions at the transport layer. Like this will verify the IP addresses before getting into the application content. So it will verify the routing decisions at the transport layer itself. It can handle millions of requests per second. After the load balancer receives the connection, it selects target from the target group for the default rule using a flow hash algorithm. It attempts to open a TCP connection to the selected target on the port specified in the listener configuration. So towards the request without modifying the headers, network load balancer support dynamic host port mapping. So what is the difference between this application network means? This application load balancer will validate the things when request receives by the load balancer at application level, content level, and then it goes to the transport level. But when it comes to network load balancer, it takes decisions and make decisions these routing and algorithms and the URLs at transport layer itself, at IP level address. So it can, because there only it has huge time, like it takes to validate the routing URL, because it has some hash algorithm concepts being formatted with the hash algorithm. So it takes time there only. So the network load balancer will concentrate things on the transport layer. Once it is done, then the transfer process the application layer content and the response from the web server. If you look at here, load balancer, basically it has some rule listener, and rule listener again it has some targets having the actual EC2 instances. Each targets have some health check configurations, and similar way rules also having some configurations against load balancer. So when request is received by the load balancer will look at the rules, the routing, the URL routing decisions being placed in the rules. It will validate the URL routing here, and it will look for the concerned target of EC2 instances. So this way how the load balancer is working in AWS servers. So this is how the network load balancer is going to work on this elastic load balancing. So what is the classic load balancer? This is the last and least, final load balancer we have in this elastic load balancer. So the classic elastic load balancer has a number of features available to help provide high availability actually. So this classic load balancer makes routing decisions at the transport layer or the application layer. So it has both features, like the validations of URL routing, the where it has to go and what is the action method and the controller name mentioned in the URL. Those decisions can be made at the transport layer or application layer. Classic load balancer currently requires a fixed relationship between the load balancer port and the container instance port. So it supports several things compared to network load balancer and application load balancer, because it is a mixing of load balance, both load balancers. So the number of features available to help providing high availability, monitoring, and better security for your application stack. This operates at layer 4 architecture. As I told you in the application load balancer, that is going to be operated on layer 7 on OSI model. But this particular classic load balancer operates at layer 4 of the OSI model. What this means is that the load balancer routes traffic between clients and the backend servers based on IP addresses and TCP port number. That's why it is allowing the layer 4 guidelines. So, for example, this elastic load balancer at a given IP address receives a request from the client on TCP port 80. That means it is a HTTP request. 80 port always HTTP request. If you say port number is 443, it is HTTPS. So it will then route that request based on the rules previously configured when setting up the load balancer to a specified port and one of the protocol or pool of the packet server. In this example, the port on which the load balancer routes to the target server will often be port 80 or 443. So that's different based on the configuration. It will change it. So the backend destination server will then fulfill the client request and send the request data back to the load balancer, which will then forward the backend server reply to the client. From the client's perspective, the request will appear to have been entirely fulfilled by the load balancer. The client will have no knowledge of the backend server or server fulfilling client request. So this is what the like relation happening on the transport layer. So the acknowledgement will not be tracked on the client place backend servers, or if you look at server fulfilling request, it only maintains the validations and server transport layer, but not acknowledgement at stuff of the client, which is being sent request to the web server, will not maintain at the client place. So using classic load balancer instead of application load balancer, we have this, like it supports EC2 classic, it supports Linode TCP and SSL listeners, supports sticky sessions using application generated cookies also. So these are the additional benefits compared to the earlier load balancers we have in AWS, because the earlier the load balancers only support EC2 VPC, virtual private cloud, not EC2 classic. But here it supports EC2 classic as well. The environment which are on AWS EC2 instances. Also, it supports both TCP, SSL listeners, and sticky sessions also available here to generate ASP.NET session ID cookies to resolve session affinity problems and session bouncing problems on load balancing. So, hope this clears like what is the load balancer and what are all the different load balancers we have on Amazon Web Services, and what are all the differences between these three load balancers. So, thanks for listening. Thank you. Please subscribe this channel for more videos on AWS.